Start recording. There we go.
There you go.
Now, if you would start again, Kevin, thank you.
Well, I'm going to change my name now that you're recording.
Okay.
My name is Kevin Witt. I co-founded an architecture firm here in Seattle named First Lamp that focuses on high performance homes. And I was the project architect on this house.
And my name is Brian Cowan, and this is Dan Bauer. We're with Carlisle Classic Homes. Dan was the superintendent on this project, and I'm the building performance specialist. So I helped with a lot of the details and blower door testing and window installation. So we started with the foundation, and we just want to kind of go through some of the passive house principles real quick. And so this is a FIAS certified passive house. So really good windows. We use triple pane windows, a non-vented roof assembly for added insulation, and strategic overhangs to help with solar heat gains and losses. And so we have an airtight envelope, continuous insulation around the whole house.
Put that.
Mechanical ventilation and heat recovery, high performance windows, and thermal bridge free construction.
I had one of those green home tours that's virtual, but they're having in person again. They have 2 sites that are virtual and one.
Can you please mute?
Sorry.
So in the scope of this, there was a duplex that was on the site that all of the wood framing was demolished. We did leave the foundation. When you're building a passive house, like Brian mentioned, one of the things that you really focus on during construction is the air tightness. And to meet passive house standards, it's very difficult to take an existing structure, one that's been there for quite a while, and make it airtight enough to meet certification. So all of the wood framing we demolished, left the foundation, and built a new house on top with an ADU in the basement. So there was 2 units there on the site. We wanted to make sure and keep 2 units there, so we're at least a net equal on density.
And so one kind of unique thing about this project is we used Icf, which is a exterior insulation finish system. So we first had a liquid applied weather barrier on the house, and then we're able to kind of trowel on some grout that would adhere foam to the outside. So in the past, Icfs have been problematic, but we were able to do all our blower door testing before we added the exterior insulation to kind of verify that there was virtually no leaks in air in the house. So that made us very confident that there would be no leaks with water. So it's kind of a new approach for a lot of us, but got great results and got it to pencil out from a cost perspective and a certification perspective.
These are just some of the pictures of the interior that we can scroll through. One of the things that helped us with the air tightness was on the main level, we used, it's kind of like a terrazzo product, but it was made to look like concrete, which was poured over the top of our air barrier. So that added a good element of durability and sort of low maintenance for the family. They have 2 small kids. And so they were looking for a house that could take a beating.
Yeah, and our floor air barrier, we taped seams on the subfloor, and then we actually overlaid that air barrier with another layer of plywood to kind of protect it through the course of construction, and be a good substrate for the terrazzo finished product.
I guess we could also note, because I don't think we did already, but for this house, because we reused that foundation, the ADU is technically outside of the building envelope for the passive house, right? So the air barrier is at the first floor framing level. So everything from there up is the certified passive house. And certainly the ADU is definitely built pretty tight. It's very comfortable down there and everything. But we use that first floor as the boundary for our passive house, kind of to avoid a bunch of subgrade work on that existing foundation.
Yeah, and that also puts us over a conditioned space, which makes it easier to achieve passive house because we're not in direct contact with the ground. We're actually over top of a conditioned structure. So these are just some pictures of the kitchen, kind of highlighting a big lift and slide door. And then, some of the collaborative designs on all the finishes and cabinets.
When you're building a passive house, obviously, like we mentioned at the top, windows and doors are, a really important component in all of the system. Energy, of course, but then again, air leakage. Every opening leaks a little bit. But you have to test the house at the end, and every opening needs to leak only very little. So once you start shopping for big feature doors like this one, I mean, this is a sliding door, but exactly how it slides and what sort of gaskets are there are like a major source of concern and a lot of focus, because the carpenters can air seal the plywood and the roof and all of that around the house, as tight as possible. And then you could get, if you pick the wrong window manufacturer, if you get a door that leaks a lot, like all of that work, it erodes how effective all that work is. And so, we start talking about, well, are the gaskets, are they brushes or are they rubber? And like, how does the door seal when it's closed? In addition to, the really obvious stuff like triple panes and, how the frame is constructed.
Yeah, and having dealt with a bunch of different types of windows and doors, I think we all kind of have a good understanding of what their limitations are. But what's really nice with these lift and slide doors is you turn that handle that's all the way on the left 180 degrees from the top position all the way down, and you physically feel the door lift up so that it can slide over. So when the door is unlifted, it's putting a lot of pressure down, which is giving us a better air seal than a traditional fiberglass door that just slides easily across a track. This doesn't move unless you lift it up.
Yeah.
And
that one active panel is probably over 400 pounds. It took 4 carpenters a fair bit of effort to install it.
Yeah. So some more shots of the kitchen.
Yeah, I think when it comes to the kitchen, one of the trickiest things that you have to watch whenever you're going for passive house certification is ventilation. How the range hood is vented. You need to get all of the those cooking particulates out of the air, especially since the house itself is so airtight. But making sure that you have a way to balance the house with all of that air going out of the house through the vent.
Try to put a PC on here.
Yeah, and there was a question about problems that might occur with the lifting mechanism repair. we haven't had any problems. You know, the mechanics of it are fairly simple, and we used a great company called Architectural Advantage Woodwork. So, you know, if anything occurred, I'm sure we could get in touch with them, and you know, but it I mean, because the panel is so heavy, you know, that equipment that lifts it is just so stout. So I think we have a lot of confidence that it will continue to but you know, the Windows indoor supply company has just been above and beyond responsive.
Yeah.
So yeah.
And when it comes to big openings like this, the lift and slide really is there's no hinges, right? So it's got the fewest moving parts and the fewest points of potential failure over the long run of any operation of a door. Plus, it's got, you know, the biggest frame to glass ratio. Like there's more of a view with this type of door than the folding door.
Operates easily. Once you lift it and it's up on its roller system, even a child can push that enormous panel. Get great functionality in that regard as well. There we go.
Yeah, so this is the some photos of the primary bedroom. Some features here are passive house windows. You can see on the left, that's a tilt turn window. So they have the ability to open it for an egress situation, or and so it would open like a door, swing into the room like a door, kind of the opposite of the way a casement window would swing out. And then it also gives the opportunity to tilt it in. So it would tilt in from the bottom so that it would sit at an angle, which gives you a little bit of ventilation and a lot of security. So you can kind of have the window open without risk of it being all the way open. And then some shots of the beautiful bathroom with two vanities. Yeah, it's a 4-bedroom, 3-bath, single family passive house over top of a accessory dwelling unit, attached accessory dwelling unit. So again, like Kevin said, retaining that density in the Wallingford neighborhood was a great outcome from the design.
One of the important things when you're designing a passive house is trying to consolidate all of your mechanical systems, and even, you know, there's a point where we're even measuring the length of the piping runs from the water heater to all of the fixtures. And so there is a lot of kind of science and care that goes into the planning of a passive house. You know, we're measuring window placements and how deep overhangs need to be. And, you know, we run energy modeling on the house. We build a 3D model, and then we take it into a software that lets us know exactly every day of the year how much each window, how much energy each window is bringing in or losing, depending on time of day and time of year. So lots of planning and care and forethought goes into the beginning, but there's so much leverage that comes from those things, because once it's done, you know, the water heater costs the same. The mechanicals are actually cheaper because they're smaller. They have less of a load. So you're sort of compared to a house that is just an energy code minimum, there's a little more forethought and more planning and a little more investment in the sort of upfront part of the project that quickly pays itself off over you know, the lifetime that you're going to be living in the house.
And so here's a picture of the three of us near the end of the project, just over there, kind of checking things over. So that's kind of the basic parts of our presentation. And then we have some more kind of technical slides to help answer questions. Does anyone have any questions?
I see some stuff in the chat. There's several messages we can look at here.
We have our wonderful homeowners answering some of these questions in the chat.
Nice.
So thank you,
Diane.
Diane.
Will you go ahead and read them out anyway, Brian, for the recording?
Yeah. So the question is that a hybrid water heater? If so, how do you manage the cold air? Is it vented to the outside? I can't see that. And Diane said, yes, it's a Rheem heat pump water heater. The cold air is recirculated into the house. The air is then warmed in a separate ducted mini split heat pump. And so when we were over there the other day, what's really cool about this is you can, so it's set up to function, all the time as a heat pump water heater. It does make a little bit of noise. So you can see kind of from this photo where we are, we're standing in front of that big lift and slide door in the kitchen. And that door to the right is the mechanical room. So on the far right exterior wall is where that heat pump water heater lives. And so the kitchen dining room is fairly close. When that runs as a heat pump water heater, it does create a bit of noise, but it's so advanced that that they have an app on the homeowners have an app on their phone where they can switch it over to electric resistance heating mode if they're having people over for dinner or want some quiet. So it doesn't have a huge energy penalty to do that for a short period of time, but it can create a lot of maybe better ambiance in the room to not hear that little motor sound in the adjacent room.
And one part of the question, we took the chat transcript down, so I'll try to remember it, but someone was asking kind of about the ventilation for that water heater. And it's worth noting that for this house, to minimize our exterior penetrations, like the range hood is recirculated into that mechanical room as well, because with the heat pump water heater, we basically made sure that the only penetrations for ventilation for the house go in and out of the Zender HRV unit. So we didn't have a lot of other ductwork or things to contend with for that. It all comes in and out of the Zender, and that works really well. There's also we used a condensing dryer in the laundry room, and everything else runs through the Zender. So kept it simple.
Yeah, if you're not going for a passive house, well, I guess across the entire industry, regardless, it's hard to beat the hybrid water heater in terms of what's available on the market. There's a few other options. The sand, and I'm sure many of you have heard they make a water heater that's has a heat exchanger on it that runs with CO2, but it's really expensive and not very many people know how to install it. If you're not building a passive house, the duct kits for the hybrid water heaters are a great solution. But from an energy loss perspective, the gains that you get, yes, you are cooling air inside the house when most of the time you want to be heating it, but your heating systems are so efficient that they override whatever losses you have from actually introducing more cold air in the house.
Yeah, and then we had some roof questions. So yeah, we did go with a standing seam metal roof. We used Adhero on the roof, so the roof assembly.
We have a picture of that.
We have some slides with it. So these are kind of our more technical things. So here's the roof assembly. We used Adhero, Solitex Adhero. And then we just have that kind of draping over onto the Icf system. So, and yeah, we
Yeah,
used,
We have
what's
a
that?
picture of the nail base on top too, I think, right?
Yeah, and then this is kind of the over insulation of the foam, and then we put a ice and water shield type membrane on the OSB there, and then put the metal roofing right on top of it. And there was a what type of heating does the house have? So we use just a couple of heat pumps that are ducted throughout the house.
So it's mini split technology with an air handler. Short duct runs.
Yeah, all the ducting is up in the conditioned attic space, other than there is one trunk that goes down to the main floor. So.
I think there might have been some other questions earlier. Someone asked about
Yeah, I'm looking.
window brand.
Yeah, so the window brand was Architectural Advantage Woodwork. So they're a company out of Kansas. They import the glazing units out of Germany, and then build the frames and the and use, you know, the European hardware, and then they shipped everything to us from there.
They were a wonderful company to work with too, top-notch customer service.
And so we have a question here from Lori. I was told that it's hard to add decking or any outside attachments to passive house. Is that true? So we just have to be really careful. You know, this house is a little easier because it's basically encased in foam. So you just kind of make sure that you know, that your exterior structure can butt up against that foam, rather than having to be kind of directly attached to the house.
It's a matter of detailing that, you know, all of the elements of a structure that cross from the inside of the house to the outside, you know, cantilevers and you know, back spans of any beams, those create what's called a thermal bridge, which basically in the winter works like a heat sink and will pull heat outside of the envelope. So that's what you're referring to. And, you know, on this house, there's lots of really deep roof overhangs and decks around the house. And we were still able to do all of the things that we really wanted to do. How they're attached to the house is where we just had to make new details. We had to kind of use a little sleight of hand and kind of go back to the drawing board and figure out how all of these things are attached to the house. But that's one of the things that I really like about the passive house certification is it's entirely performance based, right? You're looking at the performance of the energy model and the performance of the house as it's built when it comes to air tightness. And so how you get to that performance standard is, you know, really completely up to you. There's a couple of guideposts that the Department of Energy has, but for the most part, it's not a prescriptive, you know, rule-based certification path.
We have a question here. Please show the details. One of the slides we have that shows that the exterior foam on the walls and then the nail base panels on the roof, they wrap the core of the building, if you will, and then all the roof overhangs on the top of the house, and then also the mid-span roof around the middle, all the ledgers and attachments for the trusses for them go on over top of the foam. So that helps with the thermal there and makes it so you don't have the thermal bridging from framing members projecting through from the interior of the house to the exterior.
Yeah, and so this is kind of our ratio, we want to have 1/3 of our exterior insulation on the exterior of the air barrier, and then 2/3 in the cavity. So our trusses basically were designed to cut off this overhang and then add it back later. And then we were able to tailor our depth of interior insulation by attaching some, kind of stickers of wood up there that were 14 inches down, because that was the 2/3 R value. And then we just did net and blow to that. Let's see. And then here's kind of another couple pictures of that. So we had all these really tiny trusses. That thing is about, I don't know, 12 inches long.
Yeah, those are the smallest ones.
And then the different sides of the house had different sized overhangs, because that's kind of important in the goal of tailoring those solar heat gains and solar heat losses. So this is the south side of the house had kind of a more generous overhang, and we just attached those with some ledger boards and 834s. But
Yeah, a lot of what we found during the construction, some of this was, the trusses are a great example. A truss company, this is, tiny little trusses are very easy for them to make. They don't do it very often, but there's not just a whole lot of upcharge. Like, it doesn't impact the project as much as you might think, at least with regard to how much money you're spending. So there is, once you understand like the capabilities of all the people that you're working with, like the people who made the nail base, the foam on top of the roof, that was a SIPS company that basically just left one side of the plywood, one layer of plywood off of the SIPS. And so we're asking manufacturers that can, hey, can you do it just a little bit differently for us? And the answer is yes. And that speeds up production in the field, so much. Tiny trusses that are geometrically already pretty perfect that you can just attach to the side of the building like Brian described. That it's non-standard, but it's not hard particularly. Again, it just kind of comes down to planning.
The nail base manufacturing company also, in the previous slide, you might have seen there was a plumb cut in the foam where it would have lapped over those eaves. Like, they were even able to cut that for us in our factory. Like, we didn't have to do that with a hot wire or anything on site. And it was like a very minimal additional charge to do that. So it was well worth the time saved on the field side and in assembling everything. So.
And then we got a question about what we would do if the house was damaged. So, obviously repair it. The nice thing is like, as long as the house isn't changing in volume, we still have that same energy or blower door goal. So we could repair it and then kind of rerun the blower door test to kind of ensure that it's in the realm of what it has to be a passive house, and then just kind of rebuild it the same way. But
I think the answer is, anything can be repaired. It's just a question of how involved that has to get. If a large tree falls through and causes enough damage, your repairs are obviously going to be substantial, but you have the plans, you can rebuild it to how it was.
Yeah, it's not that much more than a standard or a code minimum house. I guess one way that you might think about it is like, it's almost like layers of an onion, or what it might be. The envelope of a passive house just has, one or two more layers to it. All of those things, they're materials that you find in the market. So if you're repairing a hole in your roof that you know from a tree, you just go get those same materials again, and you weave new in with the old. And so, yeah, you basically repaired a lot like you built it, and you're back to where you started.
Yeah, and then as far as like earthquake protection, you know, the house has the same building code standards that any other house would. So, you know, shear walls, you know, hold downs to the foundation. So it's designed to perform just as well as any other house in an earthquake. And then the other question was, you know, kind of why not encase the home with foam on the inside and use a commercial truss system. So one thing that Passive House is kind of known for is durability of the building. So when we talk about that ratio of exterior to interior insulation, that's designed to prevent any condensation from building up in that roof membrane or on the underside of the foam. So if you just put everything in the wall cavities, you're at a higher risk of moisture condensing on the outside of the house and causing rot or mildew or anything like that.
I think SIPs, if you're interested in building a passive house, I think SIPs are a great solution. It's hard not to build a super tight house when you're working with SIPs. Most of the time, I mean, there's sort of production and other kind of logistical barriers that many projects that consider SIPs encounter that keep them from you know, doing that. For example, it's hard to find a framing crew, you know, that will meet your project schedule, that will be able to get to your projects, that also really knows how to assemble a SIP house in the time that it takes to, you know, offset the increased material costs. So there's kind of reasons outside of passive house that a lot of you know, a lot of projects that could be good SIPs candidates don't actually wind up being built with them.
Yeah, and then so we're gonna wrap up here, and
You guys can all keep asking questions in the chat of the Wallingford Passive House folks. But we're going to move on to our next. Oops, I should turn my video on. We're going to move on to our next presenter.
awesome. Thank you all.
Yes, thanks so much, you guys. So next up, we have Aaron Sauerhoff with Earth Homes, and he's going to present the Briar Homestead. Are you there, Aaron?
Yes.
Turn on your share screen and turn on your video. There we go.
Hey, Aaron, before you get started, I'll add, if people are going to continue to ask questions about the Wallingford Passive House in the chat, please make sure that you're noting that that's the project you're asking the question of, so we don't get them confused with Earth Homes.
Beautiful.
Take it away.
Thank you so much, everyone, for putting this together. I know this is a lot of work. Thank you, everyone, for being here. There's 87 people here today. That's really, really cool. We're in a time where, you know, we have the housing crisis, we have the climate crisis, we have, you know, toxic materials all around us in our built environment, and a lot of us are starting to wake up to it. We're looking for solutions. We have solutions. We're wondering what's affordable, what's feasible, what's right for my project. And here we are gathering information, connecting, sharing stories. It's a really beautiful process. It's important right now. Welcome, everyone. My name is Aaron Sauerhoff. I'm originally from New York, and I'm actually just noticing, hold on, let me make a quick change because these blinds are way too open. Hold on one sec. Thank you. Now you can see me more clearly. Moved out here from New York about almost 10 years ago, looking for natural high performance ways of building. I traveled a lot learning about what are the ways that we've been building since we've been building. Traveled to or spent time in New Mexico, Japan, learning about clay plasters, lime plasters. I was in Portugal for a while, learning about lime. And then spent a lot of time here volunteering and working for natural builders and architects all around the Pacific Northwest. Yeah, if you want to get to know me more, just reach out. I'm very available. Love to talk, love to connect. So a few years ago, I started a company called Homes Llc. And if you haven't heard of us, let me multitask and share this. And don't worry, my contact information will be at the bottom of the presentation again. So don't worry about getting it right now. But if you've heard of, if you think you've heard of us, we were the company that recently transitioned the mitigation site in downtown Olympia into safer, more durable shelters for folks. This is what it looks like now. It was before about 100 tents. So that's where we're at. We care a lot about shelter. So the main things that, the main core values of our company are: how do we sequester carbon on a massive scale affordably? How do we use the process of building, the opportunity to build, as a method to sequester carbon and clean up our environment and actually be a climate solution? We're in the Pacific Northwest. It's really important to manage moisture. We can build, I've seen really high performance houses that are getting torn apart in 15 years because of water and air are leaking in obvious places, and sometimes not so obvious places. And like the folks at Wallingford said, with air infiltration, with air leakage comes water. It brings moisture in, it condenses behind the walls. And that's where you get mold, that's where you get rot. So it's really important to manage moisture really well. And we have these really high performance wall systems that are airtight, but not vapor permeable sometimes. So we have to create systems that are airtight and still evaporate or allow water to evaporate through. Using materials that are no or at least low VOCs, volatile organic compounds. So if we're creating airtight, high performance buildings, that means the air that we're breathing, needs to be ventilated, needs to be cleaned, needs to be free of toxic chemicals that impact our health in a lot of ways. So we're about clean air, clean water, creating durable, safe, quiet, healing spaces, because that's what homes are about. So this Briar Homestead was a really interesting opportunity to put some experiments to the test in a big way. So they wanted something healthy. They wanted natural. We went with a natural Icf system. And I'll talk about that in a second. Went with SIPs for the roof structure, all natural plasters and wood. So there was no paint in the entire house. I'm really proud to say that we built a paint-free house. And I'll talk about why we use natural plasters and some of the benefits around that. Natural heating and cooling. So we built it into a hillside. Wastewater heat recovery. I'll talk about that a little bit. So we built an airtight thermal bridge-free house at a very cost-effective price. So this house was an example to show, the motto was beyond reduction. So we keep talking about, okay, how do we reduce carbon? Let's go beyond that. How do we sequester carbon? How do we use materials that absorb VOCs and neutralize VOCs, not just eliminate them? So the layout was really simple. we had to go small because a small budget. I was built for a multi-family or a multi-generational house. The parents wanted to host and take care of the elders, their parents, along with having space for kids. So it's officially a 2-bedroom, but with a really big, there's 2 big lofts up above. I'll show that in a second. So a little sneak peek into the wall system that we used. We used a system called FazWall, and it's a natural ICF, insulated concrete form, kind of like Fox Block and other ICFs, but the material itself, what you see here, the outside, is a recycled wood pallet material, shredded up, demineralized, mixed with a little Portland cement, and then molded to create these blocks. And in these blocks are an insulation insert, either mineral wool or polyiso. In this case, we went with mineral wool. It's cleaner and cheaper, or cleaner and more natural, less carbon intensive. With this block, it's simple. You cut it with any old handsaw, any traditional wood saws, circular saw, fiber tool, whatever, or a chainsaw. We use chainsaws for carving around the windows, and then when it's finished, it looks like this. So again, you get these deep, highly insulative, airtight, natural wall systems that are extremely breathable. So moisture from the inside can get absorbed by the clay and move all the way through the wall system and evaporate out the other side. And likewise, if there's any water on the inside of the wall, it's constantly evaporating in both directions. So it's fully breathable. So the build, and I'm told that my videos might be a little choppy over Zoom, so we'll kind of play with this. Well, one of the reasons we use this building system is because it was really user-friendly and simple to build with. We hosted a few work parties and stacked all the blocks in just under 2 weeks from start to finish. So that dramatically reduced cost because we got the community involved. We got friends involved. We hosted some work parties. The homeowners were involved. They brought their family out. It was a really beautiful process. So you could see this is early on. This is late last summer. I'll just keep skipping ahead. SIPs. So what I really like about this process, this hybrid system of FazWall with SIPs, for example, is the time it takes to erect the structure and do all the high performance layers. It's all built in one. So FazWall itself, it's the structure, it's the sheathing, it's the shear, it's the wall board on the inside, it's the vapor barrier on the outside, it's the almost the siding. All you have to do is spray lime plaster on the outside and you're done. So there's no need for any membranes. There's no need for sheathing. There's no need for additional framing. It's an all-in-one system. It goes really quickly. So this is a little drone shot of us putting a SIP panel on. Again, they come in these giant panels. You crane into position, apply some sealant, fasten them together, bolt them, screw them down into the top plate, and you're done. In a nutshell. So along with that, creating an airtight, high-performance building envelope, we incorporated the Zender Hrv system. And one of the things that really stuck out and was fun to explore in this was, let me go back here, because the air intake, I'm assuming most people are familiar with how HRV systems work, right? They ventilate the air, or they take the air on the inside, they cross it through a heat exchanger from the air from the outside through air filtration, and then distribute it throughout the house. Now in this house, what we did was we built the air intake pipe through the hillside in the back. So way underground. It was about 100 feet of pipe. So no matter what temperature it is outside, the air coming into the HRV system is a constant 55 degrees, no matter what. So in the winter, it warms it up to 55, and in the summer, it cools it down to 55, and then goes through the heat exchanger, capturing any existing heat in the space. And just as a testament to how successful that system is, they haven't used any additional heating in this house. And in the middle of winter, even with the walls still wet and drying and still feeling cold, the thermometer in the inside showed 67 with no additional heat needed. That was remarkable. Just from bodies, just from, whatever heat is on the inside is there. It really stays in the system. And this was a really fun walkthrough. This shows, this is showing this corner right here, where the FAS wall corner is and where the SIPs come in and meet the FAS wall. It's showing no thermal bridging, no air leakage anywhere. And this blue you see here is the window frame itself. So that was our biggest heat loss. And I wish the budget was bigger to afford higher performance windows. We went with standard Milgard windows, which are great high performance windows, but nowhere near, they're not triple pane. They're not the best, for passive house standards. But the wall system and the roof system worked really well. See no thermal bridging, no air leakage. And the blower door test was phenomenal. We got it. We still weren't done with the air sealing on the outside because the plaster wasn't done. So we did have some air leakage where we knew we'd covered up, but we almost achieved passive house standards even before that. So in a few weeks, we're going to get another blower door test now that we're done with the plaster. And I'm expecting to achieve passive house standards. Even though we didn't go for any certifications, it's nice to know how close we can get. So the wastewater heat recovery system was really fun to do, kind of on the fly. We didn't really plan for it. It was an idea that popped up. Instead of running the water supply in a single pipe, we decided to split it up into 4 smaller units, and then wrap it around the main drain line going in the other direction, and then wrap the whole thing in insulation, and then buried it in about 12 inches of compressed earth, just gravel and earth. We make our own floor mix. This is a 12-inch natural earthen slab. No cement, no lime, just clay, gravel. It's our own mix that we make on site, and compressed, and we take, let it dry and compress. And so it's a structural slab. There's a few layers of like a fiberglass mesh netting at the bottom that reinforces it structurally, and then another layer at the top, and then it gets another finish coat that you'll see in a bit. So I want to talk about clay for a second, because this is a really important concept to our whole building system. Clay has some really interesting qualities about it. It is, when left raw, in raw form, it freely absorbs. It has an active exchange with water in the air. So the suspended water molecules get absorbed into it and released at the same time. There's exchange. But when it's released, it winds up becoming about 50 times of a smaller molecule than it did when it got absorbed. And one of the reasons that's important is because it is biochemistry of physical chemistry of water, but it ionizes the water molecule itself. So passively, forever, clay is actively ionizing, or in other words, giving an electric charge to the water, to the humidity and the moisture in the air. And what that does is it statically attracts itself, the water statically attracts itself to anything floating in the air, dust, bacteria, viruses, etc. The water attracts itself to that suspended particle, gets heavier, and falls out of the air in the form of dust. So we're noticing already that everything is, you have to dust more often, but the air itself is way cleaner. It's all just falling out of the air. And that's a forgotten principle in our building science. We used to know about this thousands of years ago, even just a few hundred years ago. Not many people know about this anymore. So one of the reasons I talk about this is because it's important to remember the natural materials and why we're using natural materials in the first place. There's some important benefits that we forgot about. This is one of them. And another one, it's beautiful. It's liquid stone. It's earth. You could imprint natural. You know, we went and collected cedar and did some stencil art in the master bedroom. Some ferns around the baseboard in the bottom. You know, this is a beautiful natural material that can be used in a number of cases. This is on the left is the shower with a waterfall feature. This is still unfinished. The whole, you know, we're just finishing up the house now. So all these pictures you'll see are a little out, you know, of showing the process itself. That's exciting. But yeah, countertops, showers, floors, between clay, stone, lime, and soap. This is a Tadillac kind of thing. An old style thing I learned in Portugal. Countertops are beautiful, simple, cost effective, very durable, cleanable, scrubbable. And beautiful. Again, the living room windows, so rounded windows, you know, clean lines, stencils. You know, the homeowner can get involved and do whatever they want in their space. That's one of the reasons I love this material. Work parties, you know, bring your friends, bring your family, and there's parts of the process that anyone can get their hands in and not worry about making a mistake, because the end of the train will come in and fix it up if need be. So we plastered the whole house in about a week time. And that's, you know, compare that to drywall hanging, finishing the drywall, priming, mudding, texture, and then paint. It's cost comparable. It's healthier. It's breathable. It's repairable, and fantastic. It's beautiful. So this is the finished product of the living room before we put trim on. This is what the plaster looks like when it's done. We use SIP panels. This is also another reason I like SIP panels on the roof is because it's easy to install tongue and groove. 1x6 pine, fir, blue pine, cedar, whatever is needed. Whatever's, you know, we've priced it out to be cost comparable to drywall and texture and paint by the time we're all done. So
Hi, Aaron.
No paint.
Are you just about ready to start taking some questions?
Yeah, very soon. I'll start skipping through. I was wondering how you know, how I'd be able to.
Okay.
I knew this would be hard to squeeze all this in, but I'll start to just go quickly. So bathroom came out gorgeous. Cedar in the ceiling. It's almost done in these pictures, but not quite. Master bedroom. I'll just leave this picture up for a moment because this is one of my favorites.
Oh,
So we used blue pine on the wall and ceiling. We have a natural clay floor, an earthen floor, clay walls, and deep windowsills. Yeah, I love the windowsills. We got all of them for about $500. 19 windowsills from a local mill guy who has been doing this for a while in Olympia. Picked out slabs with the homeowner, milled them, sanded them, oiled them, and put them in. They're beautiful. Some more progress shots of the living space. Big lofty, you know, open floating earthen architecture. It's kind of the theme I was going for. And that up there you see is an infrared ceramic panel hooked up to a thermostat as a backup. It's like, if the temperature drops, because this was so, we did energy modeling with architects and energy consultants, and we kept getting people scratching their heads saying, well, in theory, this shouldn't need any heating or cooling, but we can't really guarantee that. And so we put that in as a backup, and so far haven't needed to use it, which is kind of cool, even throughout the winter. Kitchen is just getting finished. We now have the fridge, big range in the middle, big island, big space to host, window from the loft to build, so the kids can lean in and interact with everyone in the kitchen and living room. There's that window in the loft. Big south-facing windows. I'll skip through a little bit more. So this is the outside a little. I'll skip around a little bit. You can see us putting on the lime plaster on the outside. So again, a really quick, simple process. We did the entire exterior in 2 days with just 5 of us. This is a little time lapse of us spraying the finish coat. And we did the whole finish coat in 1 day. It's breathable, repairable, durable. Requires a big overhang for sure in the Pacific Northwest. It can get the occasional sideways rain, but shouldn't get direct rain on too often. Let's see, just quickly skip through pictures because they're beautiful. They should be seen, and I want to answer questions. This is what the outside looks like now. This is a few days ago. So we're in the process of cleaning up the site. The owners are moving in. So yeah, I want to jump to questions. This is exciting for me. Happy to be here. I wish I could have been more prepared, but I've been really focusing on finishing up this project. So this presentation was a little last minute. So I appreciate y'all bearing with me and enjoying these beautiful pictures. Let me bring my attention for the first time to the chat to see what y'all are curious about. Checking in on time. What is our timeline
We have
like right
5
now?
minutes for questions left.
Okay. And again, please feel free to
sum up
read.
too if you want.
Sure. Yeah. And again, for everyone, just please feel free to shoot me that number you see on the screen is a textable number that goes directly to me. I can always be contacted, text, call, email, whatever you wish.
So Laura says, love those counters, Earth Homes. What are they made of again?
Yeah, so the counters are kind of a hybrid mix. We're still experimenting with this. It's a mix between traditional Tadalact system. It's lime finished in a very particular certain way with chemical reaction from olive soap, and a little bit of what we've learned, stuff from this system called Decopause. It's a recycled polymerized, natural polymerized cement. It's like a soy-based cement that has its own sealer system and everything. So we're still playing around and experimenting, but I think we've done plenty of showers and floors and countertops, and I've seen the years of testing of testing that goes in. But it's a mix we make ourselves.
I'm going to jump to Shauna. Are you both the builder and the designer, or one or the other?
Indeed, yeah. So my main role is the lead designer. So I designed the house from scratch with the clients, custom for them. And I was the general contractor for this build. But one of the results of this build, our company's we've taken all of our project managers and we kind of split up. So I helped everyone establish their own contracting companies with their own license, bond, insurance. And now we've become more of a network. And so my role is design and project management and construction management facilitation, and to connect the client then with the appropriate contractor to help make it happen. But yeah, I'm the designer at this point.
Angie says, can you repeat the heating and cooling method you used with the pipes submerged in the north-facing earth mound?
Yeah, cool. So behind the house, we kind of see it here. Oh, he's blocking the air intake. But so the HRV system is on the other side of the house from this. And the air intake travels through an 8-inch pipe through just above the footer, buried about 10 feet below, under the hill, through the back of the house. It goes about 80 something feet before it enters the house. And so when we measure the temperature of the air coming in, it's 55 degrees always. The earth, just a few feet below the surface, is a constant temperature of 55, between 52 and 57 or so, depending on where in the world you are. And in here it's about 55. So in the winter, when it's 32 out, or less, the air coming into the house, into the HRV system, is 55 degrees. And then before it goes through the heat exchanger, capturing or recapturing any of the existing heat that you already have in the space. And it worked. And then in the summer, it's cooling it down to 55 before entering the heat exchanger.
I think we're going to go a couple minutes over the schedule with questions here because our first presenters started a little early. So I want to give Aaron the same amount of time.
Oh, thank you.
I have a couple more questions here for you. Liana says, does plaster everywhere interfere with Wi-Fi cell signal strength?
That's a really good question. So the gravel, the aggregates that we use here locally, were all basalt, because that's just the crushed gravel that comes out of our local quarries. And one of the reasons I was excited about using basalt was that it does have EMF blocking properties to it. And we weren't sure how that would do in terms of Wi-Fi signal or cell service. But yeah, there was already really low service on this land. But as soon as you walk into the house, cell service goes out completely. It is kind of weird. Wi-Fi is fine. There's plenty of Wi-Fi in the house, and it bounces throughout the rooms and doesn't interfere in that way. And we also put Ethernet ports. They wanted to be able to turn off their Wi-Fi and have Ethernet ports, so we did that anyway. So when we scan for EMF from the wires and the outlets, we get nothing from the wires because they're behind about an inch of plaster, buried in the wall. So the EMF levels in this house are virtually nothing unless you're right next to an outlet or a device or an appliance. Yeah, the plaster does have EMF blocking properties, which has Wi-Fi or cell service impacts as well. Some could see that as a pro or a con.
And Bernice asks, how difficult was it to get structural engineering and permitting?
Permitting was a cake. It took 2 weeks. No issues, no questions. Engineering was really simple, really straightforward. I have a network of engineers that are familiar with timber frames, straw bale, hempcrete, ICFs, SIPs, and retaining wall, and just weird creative systems that we used. One of the weird details, let me just share this real quick. I'll go straight into my program here. One of the weird details structurally that was challenging to get approved, or just took a little extra time, was this inner part where this steel beam that's hidden. Let me just go to that detail. This steel beam that's hidden in the wall system is a 20-foot or 26-foot steel beam with an angle iron welded onto it that then holds the SIP panel. So we created this detail custom with the engineer that we had ourselves and the engineer from the SIP manufacturer And I put their heads together and I said, you guys, please figure this out, because I want to be able to attach and, float this roof structure and achieve this architecturally. And so this was a little bit of a challenge, but we did it. We figured out a really good system. And then we welded a pipe to the bottom of the beam that then suspends this other LVL beam that then holds 14 feet of the loft in the air. So there's some really creative engineering that happened with this, but overall, it really wasn't that big of a deal. The retaining wall was a big deal structurally. I definitely would do that differently. It posed some challenges, but otherwise, engineering behind this was quite simple and straightforward. And mostly, one of the feedbacks I got from the engineers, because of what I did in my drafting world, just in my modeling, this software that I used, I'm able to come in and model the house in full 3D with every component built in. And that made it really nice for the engineers to work with, because I know their systems really well too.
I'm going to do one follow-up question here, and then I'll have you go to the chat and answer questions that we didn't get to. But Laura asked, would Lewis County or Centralia have let you occupy without a heat system?
So we do technically have a well, there's 2 heat systems. And no, they wouldn't. For energy code sake and permitting, we did put the infrared panel. And we also have, let's see, where can I show it? We do have also a, let's see, where the hell do I have it? We have a little tiny wood burning stove as a backup source, because power goes out in this valley 20% of the winters. And so we needed something not reliant on electricity or the system. So we do have a wood burning stove that is airtight, has its own air intake, super high performance, tiny wood burning stove. So that is a thing. And with a really long flue that goes all the way up to the top. So a tiny fire in that will roast the house. I mean, it brings it, we've brought it up to 79 really quickly. So we're like, okay, let's calm down with the heat. We really don't need heat. But yeah, for permitting sake, we did have to add some things that we knew would be unnecessary. So that's an energy code issue for another talk.
Great, thanks a lot, Aaron.
Yeah.
That's really informative. And like I said, please go to the chat and look for some additional questions that you can answer there. And we're going to bring Wallingford Passive House back up again for those of you who weren't here at the beginning. You get to learn about our other virtual site today.
Yeah, and thank you everyone so much for being with us on this today and checking this out. Any questions that I didn't answer, please feel free to shoot me a direct message, text, email, or call me later. I'm
Yeah, go ahead and put your email in the chat again, Aaron, for
Indeed.
people who came in a little later.
Thank you very much.
Okay. So, so we have Brian. Is Dan still there off screen?
Yep.
There he is.
Yeah.
Brian, Kevin, and Dan, and I'm going to let them introduce themselves. Wallingford Passive House.
My name is Kevin Witt. I co-founded an architecture firm here in the Seattle area called First Lamp. We focus on almost entirely homes and high efficiency homes at that. And I was the project architect on this project.
And my name is Brian Cowan, and here with Dan Bauer. Dan Bauer was the superintendent on this project. I'm the building performance specialist at Carlisle Classic Homes. So I helped with window install, detailing, blower door testing, general passive house questions. So here's the front exterior photos of the house. And we kind of inherited this foundation. This was a duplex house, and we tore it down to the foundation, and then decided to build a ADU in the basement. So this is a certified passive house. So we had some really awesome windows in there. Some really awesome details to prevent solar heat gain or manage solar heat gain. So the 5 passive house principles are an airtight envelope, thermal insulation, so continuous insulation around the house, mechanical ventilation and heat recovery, high performance windows, and thermal bridge free construction. And so what's unique about this house, or was new to us, is that we used Icf's, an exterior insulated finish system. So what that means is there's a foam layer on the outside that then gets stuccoed over to create the exterior facade. This system was fairly new to us, but and has a history of some challenges in the past, we'll say. But what was an advantage in this passive house system is we were able to put on, so there's a airtight liquid applied rain barrier or weather barrier on the house. And so before we put up the foam, we were able to do our blower door test and verify that the house was very, very tight, and leaking walls was kind of the initial problem with these systems when they were kind of in vogue in the 80s. But with the liquid applied air barrier, we're able to kind of curb all of those concerns by ensuring that the house is going to stay dry.
And here's a shot of the interior just inside the front door. Like Brian mentioned, one of the cornerstones of getting a house to be a certified passive house is making the envelope as airtight as you possibly can. It's really difficult if you're working with an existing foundation. And so the solution here is basically it's, there's 3 levels to the house. The basement level is an ADU, and then the top 2 levels are the certified passive house. And so we're standing here. What you see in the shot is the floor of the main level of the passive house. So we used a terrazzo-like product. It's a cementitious product that is incredibly durable, which was a big benefit to the owners. They have a couple of small kids, and they're looking, durability ranked pretty high in, the things that they were looking for out of a flooring product. And all of the air sealing and everything happened underneath this. So there's, 2 layers of plywood. The first structural layer received, a similar liquid applied air barrier that really can, as a liquid, it sort of settles into all of the cracks and then stays pliable. It stays flexible over the course of the life of the house, which is an important characteristic also. And so, yeah, it's just a little bit of backstory there. With the windows, windows are another really important part of the house, particularly when it comes to air tightness. A lot of people think first of energy efficiency, which is important, but every window leaks air a little bit. And there is a limit to the amount of air leakage that a passive house is allowed to have. And so you really start to pay attention to how well the windows are made. And then, this door that we're looking at here It's very important. There's a lot of edges on this for an operable door that, if constructed poorly, would allow air to sort of leak in. So these are all really important things as you're shopping for windows and doors in a passive house. This is a lift and slide door. It's hard to beat a lift and slide when it comes to, if you're looking for a product that has the highest air sealing capabilities. The gasketing and the operation and all the kind of mechanics of the door are as simple as they get. And so, this is, you get to have both. A lot of people think energy efficiency means you're eliminating windows and eliminating glass. That's actually just not true. You are more focused about where you put the windows and the overhangs above the windows, because you really need the sun's energy. You need to harness that in order to help you with the heating load of the house. And so that, the image that we're looking at here is a great example. Plus all of the other stuff outside of energy efficiency that are pretty straightforward with a house these days. You want the kitchen to be connected to the backyard. All of those things sort of outside of energy awareness.
And so here's some more shots of the kitchen. A great kind of collaboration between the clients, the builders, the architect, to put together just a wonderful functional look. A lot of nice lighting, nice natural lighting through that lift and slide door. This is the primary bedroom. You can see in the photo in the upper left, that's a tilt turn window. So a triple pane window that's gonna have a really good R value. It's also going to give you the option to kind of open it like an in-swing door, or tilt it so that it opens just a little ventilation at the top. And then you can see some of the spectacular finishes in the bathroom on the right, two really neat vanities. It's a four bedroom, 3-bath, single family passive house with a attached ADU below it. So it started as a duplex, and we were able to retain that density there.
So when you're on this project, from the outset, the goal was passive house certification. And so much of the things that are going to get you to that really come down to planning. We were, one of the things that you have to submit as part of your certification package is the length of plumbing runs from your water heater to all of the fixtures in the house. So a lot of measuring, a lot of checking, a lot of energy modeling for the house. So, all of this, it really comes into play at the very beginning. Like, you have to locate your mechanical room central to the house. And a lot of, many houses say that they've done that, but it really becomes a priority. And if you assume that in the planning phase, a lot of the other pieces fall into place relatively easily. And so, the mechanical room and the mud room and the sort of back of house entry are all one space, kind of built for durability that way. The water heater in this house is a hybrid water heater. For any energy efficient homes, it's hard to beat just the availability, the price, and the effectiveness and the efficiency of a hybrid water heater. It's nice that it's electric, not relying on natural gas. we've had some questions in the past. It's common, people have a little bit of concern about the fact that the heat pump on the hybrid water heater does cool the air in the room. That's another reason that we located it here in the mud room, sort of a utilitarian space. From an energy loss perspective, the heating systems for the house, more than the efficiency of those, more than cover up the extra load that they assume by heating the air that the water heater has cooled ever so often. So the benefits of having these systems certainly outweigh the downsides.
Yeah, and we got a question from John Erickson in the chat about evaluating window efficiency and relying on the R value. So one of the things that one of the advantages with doing a FIAS certified passive house is that there's kind of a level of oversight on all these things. So we can't just take the manufacturer's data as as the R value. They want to see some kind of supporting documents, and then we also have to put it into an energy model. So we're looking at a lot more than the R value at center of glass, which is what you're typically getting when you ask about R value. We're inputting what's called the psi spacer value, which is how efficient some of the other components in the window are. The R value of the frame, how big is the frame, how big is the glass portion, and then the energy model, which is called WFI, is analyzing all of those places where there could be heat loss and heat gains through the window in a vacuum, but putting that window in the proper place with the proper orientation to the sun, other shading factors. So the model is aware of all the other impacts of that window, whereas the R value just tells you what the center of glass is, and that may be the most efficient part of the window, or it may be the least efficient part of the window. So passive house kind of gives you a way more detailed analysis with being able to kind of choose windows based on a number of factors.
And not just to that point, not just choose windows, but when we were designing the house, you can make real-time changes to the energy model. And so we were deciding the depths of all of the roof overhangs down to the inch, because we were able to update the energy model and say, well, what if we made this overhang 3 inches deeper? And you get real-time feedback from that, and it's incredibly valuable to be able to implement that into the design, knowing that we made this overhang 3 inches deeper, and it really changes the performance of the house in the spring and the fall. A very meaningful amount, and it's because of that fidelity of information that you have that Brian was describing. About all of the way that the windows perform, which way they face. The model takes into account trees and buildings surrounding the subject property itself. So it's passive house is an entirely performance-based certification path. They don't really tell you how to get there. They just make you measure the whole time and sort of show your math. And it really is based on how the house actually performs from an energy perspective.
And so windows are always kind of going to be the weakest link in any wall system. There's they're more likely to have a small amount of air leakage than a similar sized, well-detailed portion of wall. They're going to have a lower R value. In our climate zone, 4C, it's a little less of a challenge. We're in a little milder climate, but the one thing that's kind of really neat about the Passive House US certification is it takes into account the exact area that you're at. So when running our model, one of the most important questions is, you know, what climate zone are we in, but what kind of microclimate are we in? So the windows are really you know, analyzed for exactly that house with that orientation.
And to his point, there's some questions coming in about, you know, windows. The house really does rely on harvesting energy from the sun. Like we need, in the winter time, we are relying on gains, solar gains. The only places where a window is just a penalty entirely is on the north face of the building. And yes, you can see that in the energy model, because in that circumstance, you don't get any solar gain. It is, from an energy perspective, a hole in an otherwise really nice, tight, you know, thermally tight system. You worry a little bit about a lot of western facing windows because it is very easy to overheat a passive house in the summertime. So north and west windows are really pretty tricky. You have to be careful about where you place them. And, you know, to that extent, having a house whose footprint is longer on the south and north sides is an advantage, because that southern face really is where you get all your leverage and all your control over being able to heat the house, because you can put a lot of windows there and cover them. The sun doesn't come in the windows in the summertime, but as the sun is lower in the winter, you get to take advantage of all those gains.
Do you want to put in your contact info?
Oh, yeah. Yeah, my email address. Oh, I don't have my glasses on. I can't type. Brian's gonna enter my email address. It's kevin@firstlamp.net.
Yeah. So
slides. There we go.
So here's kind of the back side of the house, with all three of us near kind of the end of the project. And now we'll kind of go through some of the detail slides.
Just really quickly here, this makes my point. Like, this is the western face of the building. And so even there's really not any overhang deep enough that will ever prevent, you know, late afternoon sun coming into a western window. So that's why windows on this side of the house were scarce. You know, you rely on gains from eastern windows to warm the house up in the morning time. So that other shot with all of us standing there on the back patio, those were, you know, that was an east facing facade.
So bigger windows here on the east and a little smaller on the west.
On the east too.
Yep.
And so here's a picture of the floor system. We did liquid applied everywhere in the house, but we did just do plywood OSB with the seams taped for the kind of main floor area there. So continuous air barrier. You know, these are kind of our you know, design criteria for the windows. You know, there's a ton of options out there. We went with a company called Advantage Architectural Woodwork, and they are out of Kansas, and they import the triple pane glass from Germany, and as well as the kind of tilt turn European hardware, and then you know, manufacture the windows there and ship them over. So yeah, just great products. There's a whole ton of windows out there. There are some, you know, brands you may have heard of, like Lowen, that are moving into the passive house market, but as you start to look for passive house windows, you'll find an entirely new suite of of options out there. Yeah. So triple pane design, here's some photos of us installing them. They're really heavy, really sturdy windows.
Really good fit and finish though. They did a very nice job on those frames.
Yeah. And so here's kind of one of the challenges and opportunities with the roof system, you know, so this is kind of a traditional roof overhang. It extends way out. It's kind of like a heat sink fan, you know, it gives us a lot of connection to the outdoors. And we can't really insulate around it without going around the whole thing, which adds, you know, more complication, a lot more materials, a bulkier look. So we kind of clip that detail off and then add it later. So we get to this point where we can kind of, our blue line is our air barrier, and then outside of that we have our continuous insulation, and then we add that critical overhang, but it's independent. So here's some photos of that. So this is kind of at this stage, we're at kind of a conventional construction, the way you would do a normal house, where you have plywood on the roof for sheathing, and then we put a self-adhered membrane on there. But then we add our layers of insulation on the outside, and then this these mini trusses. So they're different sizes based on, you know, the north side doesn't need big overhangs because we're not trying to shed any sunlight there. And then on top of that, this is where it gets, you know, kind of unique to passive houses. We're putting exterior, or unique to high performance building, we're putting exterior insulation there. We're not venting our roof. We're having a certain amount out there. So what we end up, the outcome is we have a third of the insulation above the sheathing and 2/3 in the ceiling cavity. So that helps us stave off any condensation risk being around that sheathing. So we don't want to create any rot or any moisture damage in the wall. So by kind of adhering to this ratio, we can kind of hedge against that. So here's a photo of some of us up in the attic there. You can see the blown in insulation on the inside, and then our mechanical system is inside of the thermal envelope. So wall is just kind of a regular interior wall with 2 inches of exterior insulation on it. Here's some of our performance numbers. The orange lines are kind of our target, and the blue graph is where we are with the energy model. So you can see we're well below on a lot of these things. The source energy is a little close, but all the other air tightness, we ended up being way tighter than we needed to be. So that was a testament to our work, the work of the company that did the siding, and just kind of being very attentive to detail. We did a couple blower door tests throughout the project to really make sure that we were you know, sealing any penetration and detailing around to make sure no water gets in the house. So here's our blower door day. So I think our goal, this was our first test. Our goal is to be under 360 CFM, and we came in at 240. And then I think it further decreased from there when we did our final.
It did. At that point in time, we actually still had a couple fairly key components we hadn't fully assembled yet. So we were very happy to see that we were getting the numbers we needed, you know, when the entire system, if you will, wasn't actually fully assembled. So again, that shows kind of testament to the design details and the implementation in the field working really well.
Yeah, air leakage is a component of energy awareness that surprises a lot of people who are just sort of getting into and learning about high performance homes. The truth is, like, as homes, as it became much more common to insulate homes, sometime around the late 80s, early 90s, people realized that energy loss from houses, built to code minimums, then 40% of their energy was being lost through air leakage. A standard home changes its air, the entire volume of its air out 6 or 7 times per hour under normal weather conditions. Wind blowing outside is really plays a big part in that. And so if you're exchanging your air 100% 5 or 6 times an hour, I mean, your heating and cooling system has to condition that air. And so air tightness becomes, a major thing to look after because in comparison, insulation is relatively easy. You just add more if you need it. Air tightness takes planning and the right materials, and there's logistics and there's sequencing things that are involved during the build that you have to pay attention to.
And durability too. So insulation is going to kind of retain those properties over time, as long as it's continuous. And some of the air sealing, like around windows and doors, there's going to be some movement in those components. You want to select materials that are going to be up for the unique challenges for every kind of component that you're putting in. So whether it's so that you can use tapes, you can use sealants, you can use foams, and in different scenarios we use different things. So for our flooring system, we knew it was going to be kind of covered by another layer of OSB and then the terrazzo. So we were able to just put tape the seams and be confident that that was going to be stay on the test of time there, because it's kind of entombed. Whereas like there were some other details where we added layers of tape and then liquid applied on top of the tape and then more tape and more liquid applied, where we really needed to have a detail that's very three-dimensional, could move over time, and those always end up being in the hard to reach spots anyway. So finding the way to seal some of those tricky details is important. But on this house, a lot of the details were very straightforward, with a few small exceptions.
See a comment from Evan and Diane in the chat that we couldn't agree with more. In fact, before we started, the three of us were just kind of conversationally trading stories about having built houses other than passive houses and how much they leak, like contemporary houses, in the recent years. And Evan's right, a vented attic, even if you seal the drywall, you're sealing up really tight, which is really hard to do. You have air coming from around recessed cans. Air makes it into the wall cavity. We've done blower door tests before with vented attics where you can feel the air coming out of light switches in the walls on the top floor, or electrical receptacles, because even if the lid is tight, there is no real seal between the top of the wall framing and the stud cavities. So air just comes from your vented attic straight down into your walls, and it really gets everywhere. So part of the planning process in building a passive house is planning for the simplest geometric envelope that you could possibly design. And by that, I mean, like the drawing that we were looking at earlier, not having your air barrier go all the way out to the edge of your roof overhang and then back to your walls. You really want to make it a nice, neat sort of gift wrap. And then add your overhangs, your decks, and all of those things on the outside of your air barrier really is a much better way to kind of set yourself up for success.
All right, with that, I'm going to cut you guys off because we are running a little behind schedule.
Okay.
Thank you so much for giving that in-depth look at your design and build.
Yeah, and if people still have questions, you can put them in the chat and just reference Wallingford Passive House, and we can type up a response for you. So thank you all for watching. And letting us share. Thank you, Jenny.
Thank you.
Thanks. So I'm going to bring Aaron Sauerhoff back on to talk about Earth Homes for those of you who may have missed his presentation the first time around. And we're going to leave this this Zoom meeting on past 11 o'clock for those of you who can hang around through this next presentation. We'll have the room open until 11:30, so you'll have time to ask Aaron questions as well about his presentation, his build. So Aaron, do you want to introduce yourself and let us see what you've been working on?
Indeed.
Oh, I did want to mention that, or maybe I already did, we will be sending out the recording of this to everyone, as well as a link to the chat, because there's lots of great information in the chat. After the tour through Eventbrite, we'll send an email, and we'll also be opening up some new recordings from the past virtual tours, and you'll have access to those as well. And thanks everyone for listening.
Beautiful. Thank you so much, Jenny. Thank you for the folks at Wallingford, Wallingford Passive House for talking so deeply about the importance of air tightness. It really is critical and key. And the design principles that you spoke to, like simplifying the envelope, attention to detail on some of those layers, just really it matters, and it pays off. So thanks all for speaking to that. Hello everyone, thanks for being here. I'm curious how many of the 54 people here are still here from the first half, or kind of hopped in late and want to see this presentation for the first time. But I'm gonna give it again, and this is gonna be fun. Greetings, my name is Aaron Sauerhoff. I moved here about 10 years ago from New York with a deep desire to learn about all the ways that we've been building since we've been building. So I traveled from Portugal and Europe to New Mexico to Japan, and learning what are the traditional ways to use natural materials in a high performance way. So my educational background was around building science and moisture management and air tightness, a lot of passive house stuff, a lot of LEED, a lot of living building challenge was a huge passion of mine educationally. And I was always curious when I was looking at these schools of thought and design principles. So I was asking, well, how can we use more natural carbon sequestering material in an affordable way that achieves these performance outcomes: air tightness, moisture management, thermal, reducing the amount of thermal bridging, efficient modular type, accessible construction, all those things. So let me share my screen and I'll walk you through what we've done. Oh, wow, I should have went all the way to the front. Oh, cool. Don't worry, my contact information will be at the end of the presentation again, and I'll leave it in the chat. So don't worry about grabbing it right now. But so a few years ago, I started this company to really figure out those things. How do we sequester? Our main mission is to sequester. That means draw down as much carbon as possible, store it into our building materials, and use store carbon in our building envelope. How do we use the process of building to to enact climate solutions. Here in the Pacific Northwest, moisture is a huge problem. I spent years tearing apart old, doing a lot of rot repair. I've seen what tiny leaks can do to whole houses, and it's not pretty. So I know that I've studied in person and in the classroom and on my own the impacts of moisture, not just liquid water, but humidity leaking through it, through an air leak, and condensing behind a wall, behind drywall. You'd be surprised how much black mold is in the cavities from the unventilated or from the ventilated attic system, just pouring down the walls. It condenses in these colder spaces and leads to mold, and that leads to health problems that sometimes are untraceable until older years. Why do I have heart issues, respiratory things, autoimmune things? A lot of it can be traced back to clean air, clean water. And now we're spending so much time breathing the air in our homes. Let's focus on clean air in our homes for a bit also. So that's what we bring to the table from a design and consulting standpoint. And we have a network of contractors that build naturally in high performance systems. So if you've heard of our company before, the most recent thing that we were in the news about was transforming the mitigation site in downtown Olympia. We built 65 micro shelters and transformed what was a city-owned parking lot that was legal tent camping into a transitional temporary shelter with door to lock and provide case management and everything. So this project I want to talk about, Briar Homestead, was a really cool opportunity to experiment, to really bring together some big separate experiments that we've done and see it all work and see how high, how airtight, how high performance can we go at a pretty small budget, and some tight time constraints, etc. So we went with we first went with straw bale, and after the fact, looking back, I think we definitely could have and maybe should have stuck with straw bale, but that's for another topic. But we went with a natural ICF. It stands for insulated concrete forms. And I'll talk about those in a bit. The roof system, we went with SIPs because very high performance, relatively low cost, and very quick to install. Inside and out, we went with natural plasters. I'll talk about that. We went with a natural heating and cooling system. So a lot of passive heating, passive cooling. Talk about that too. A wastewater heat recovery. So a lot of heat gets poured down our drains when we're doing dishes, taking a shower, doing laundry. So all that water that heat is extracted and used to preheat the water that's coming into the hot water heater. So we'll talk about that and how we achieve the airtight thermal bridge free house in a very cost effective way. So this is about beyond reduction, not just reducing our carbon footprint, but sequestering it. So the layout was really simple. They wanted a multi-generational family compound on 5 acres, south-facing hillside. And we designed it from scratch. This is the final iteration that we wound up building. They went with one big bathroom in the middle that had different stations that achieved their own privacy. A master bed with a big loft that came all the way up here. And then the master suite or master bedroom for the grandparents. It's all ADA accessible in this area, in the bathroom as well. Well, not certified ADA, but close enough as best as we can get. Open floor plan, living room and kitchen layout. They wanted to be able to host. They wanted, kids to be able to interact from the upstairs loft in here. Root cellar built into the hillside, completely underground. A lot of space. They're big into ferments, canning, wines, and all that. Lots of south-facing windows. I'll talk about that and why that's important with the passive heating. And then notice where the HRV system comes in. the air intake, and I'll show this later, but the air intake for that travels behind the house, totally buried in the hillside. And that's a big component of the passive heating and cooling that I'll talk about in a bit. So the ICF or the natural ICF blocks that we use are called Faswall, and they're made in Oregon. And it's a recycled wood pallet mix that's demineralized, well, shredded up, demineralized, mixed with a little bit of Portland cement and molded into these blocks. And it has an insulation insert that achieves R26 technically, but performs way better than that, especially once you add the plaster on each side. You have a fully finished monolithic structural panel system that doesn't need any membranes, doesn't need any sheathing panels, doesn't need any more foam. You just stack the blocks, pour the concrete, spray the plaster, finish it, and you're done. So it's a very quick, efficient, high performance wall system done at cost. You can cut it with any traditional wood tools. We used a chainsaw to route out or to carve out the windows that give us a big round open, open space for the windows. You get a big deep nook. It's fantastic. The build itself, and pardon the choppy videos, I'm told that these videos come through pretty choppy, so I'll just fast forward and show what the build process looks like a little bit, because, and same thing with straw bale. One of the reasons I like these systems is because it's accessible to get your friends, family, neighbors involved. You don't need experience to hop in and plug in and help. As long as you have a few people coordinating and leading the teams, it goes really smoothly. And it's, you check everything, you make sure there's no mistakes, and then you pour. So we stacked the blocks. We had a few work parties, and we stacked the blocks in a mere 2 weeks. We were done, including all the pours. So a very quick process. And then very soon after, the SIP panels are ready to be put on. And that process goes really quick. I mean, here's a quick little video on what that looks like. But the SIP panels can, simple, craned in, sealed, with the splines installed, and you're done. So if you notice the top of the Faswall blocks have, basically treat it like a giant stem wall. So you do put J-bolts at the top, install a sill plate, and then and the SIP panels get screwed right down to that. Very, very simple, clean, efficient. So with the airtight building and no thermal bridging, we went with a Zender Hrv system that recirculates the air or that replaces the air inside the house every few hours through a heat exchanger. So it captures the existing heat in the space and transfers it into the incoming air. I won't talk too much about that, but it's a really important component of the modeling here. It was very successful. This is a scan of a corner where the Faswall meets itself and the SIP panels land on top, and you see no thermal bridging in the seams, no air leaking, no thermal bridging. The blue here you see is just a window, and so we didn't go with super high performance windows. We had to kind of we had to make a budget decision on that. So that's where most of our performance issues were seen. It was around all the windows. We went with the standard Milgard windows. They're still high performance. They're made in Tacoma, so they're very local. It's a cost-effective way to do that. The heat recovery through the pipes is really cool. So the drain line in the left, you see the drain water is going out to the septic, but the incoming, instead of running one main line to the water heater, we split it up into 4 lines, so it slows it way down. Spiral it around in the opposite direction, spiral it around the drain line, so that it slowly captures that heat as it's moving towards the water heater. Wrap the whole thing in insulation, and then buried it in our own mix we make. This was a a foot thick, so 12 inches of compacted earth, I'll call it. Just, clay, gravel, and some fibrous additions. And that's floating on top of 3 inches of foam with a vapor barrier on top. So it becomes a structural slab without any concrete or lime at all. So nothing that's curing. It's just, it solidifies into a rock hard compacted earth slab. It's nice. I want to talk about clay for a bit. I know I'm going to rush on time, so pardon the bombardment of technical scientific information, but the reason we use clay, and this is something that we forgot, hundreds of years ago as a society, clay has a really interesting relationship with water. It freely absorbs water molecules and releases them in this continuous passive exchange that's happening with the humidity in the air. So the water molecule gets absorbed and gets released at about 50 times smaller than it came in at. And the reason that's important is because when the water molecule comes out smaller, it now has a negative charge to it. So it's electrified, it's ionized. And that water molecule suspended in the air will now electrostatically attract itself to anything else floating in the air. Dust, viruses, bacteria, protists, whatever is in the air is attracting water. It makes it heavier and now slowly falls out of the air in the form of dust that you got to dust a little more often, but now you're not breathing it in, which is key. It also has a VOC neutralizing effect. So anything that touches the clay, don't really know exactly how it works, but it's kind of wild. It neutralizes VOCs, volatile organic compounds, which is really key for human health and happiness. Clay is also a beautiful, beautiful material. It's liquid stone. We make our own plasters in-house. We have a special blend we make. It's all natural, super high performance, super durable, breathable, airtight. And I want to mention that someone asked about this last thing, the difference between breathable and airtight. It's really important. So we need the airtight component. Air shouldn't go through, but it needs to be, when I say breathable, I mean vapor permeable. So water being able to absorb in and evaporate back out. That's really key. Kind of like a Gore-Tex jacket. When you sweat in it, it's going to stop the liquid water from going through, but it'll allow the sweat to evaporate back out. That's what we need our wall systems to operate in the Pacific Northwest if we're going to use natural materials such as straw bale, hempcrete, cob, Faswall, etc. So that's really key. Clay is great for that. So we use clay on the inside and lime on the outside for that very reason. This is in their loft in the master suite. Ferns are coming up the baseboard, cedar from the forest along the top. The blends of plasters that we have and we make can be used for countertops, showers, floors, walls, etc. This is the countertop in the kitchen. Incredibly durable. Good luck scratching it. I mean, you could definitely chip it, but it's repairable, it's fixable, it's malleable. But we use it for showers, countertops, walls. Water will bead off it. It's scrubbable. It's great. This is in the living room. We were playing with more imprints, and they just kind of. So the homeowner was involved and was just having a blast all week with us, just finding different ways to create art on their walls. They got this is the homeowner's friends and family that came out and helped plug in and smear some mud around. So this is the end of the process of plastering before we put any trim on or any of the wall sconces. But it's beautiful. You see big round windows. And the reason why the south facing windows are so key also is because the thick earthen slab in the floor is what we think of as a heat battery. So as the sun comes in the winter months at a low angle and comes in direct contact with the floor, even when it's cloudy, infrared is still coming through and heating up the floor just slightly. It's then going to slowly re-radiate that heat throughout the day back into the walls. That'll absorb it, and then it'll go back out from there. So you're storing the heat in the thermal mass of the building itself, which is really key and not often talked about in performance building. But it's an important part of our modeling system here to buffer the fluctuations thermally The clay buffers the moisture fluctuations and humidity. There you go. Bathroom came out beautifully. This is before we had the countertop over here, as we just finished the plaster. Cedar on the ceilings. So something I'm proud to say is that this house is officially paint free. There's no paint. It's all plaster. It's all pigmented plaster with natural mineral based pigments. Make everything ourselves on site. It's really simple. We can, we're now starting to make it in buckets in our compound. Can supply the materials to anyone. Show people how to use it. This is right after we did the floor, the finished floor in the grandparents' suite. So I love this picture. I'll leave this up for a moment. We used blue pine tongue and groove for the wall into ceiling transition, and then clay plaster walls and clay plaster floor, earthen floor, I'll call it. You could also call it a compressed earthen floor or whatever. And it's beautiful. It lasts. Windowsills are all local milled maple. Very simple, wildly simple to do. We milled it we got the raw slabs, milled it in our planer, sanded it, and then set up the homeowner, because they wanted to help set up the homeowner with a little oiling station, and he sanded it and oiled it, and then we plugged it in. But 19 windowsills cost us $500, and they're beautiful. This is the lights turning on for the first time. We're super excited. This is the living room, kind of open space here. And the thing I love about this design is how open and floaty the structure feels in here. There's a lot of weight. There's a lot of, with the plaster walls, it feels very earthen, very heavy, and it is very heavy, but it's floating, and it was very relatively simple to do this structurally, but it gives a really good feel. And something I would do next time is extend this loft out a little bit to give it more of an overhang over these interior walls. And so all these interior walls are technically floating. They're hanging from the loft structure above. There's a structural spine that supports all of it. And that streamlined everything with the floor slab being an earthen slab. We kind of needed to do that. Kitchen, this is before we put in the fridge, the island in the middle, the range, big thing. Up in the loft here, I'll show you in this next picture. There's a window that that's their kids' loft. They can lean over and interact with the grandparents in the couch in the living room, and the people, the friends that the parents are hosting at the island in the kitchen. So that's like the multi-generational swirling dynamic flow that we designed into this house. There's a lot of we designed for interaction. We designed for movement of people, for noise, for moisture, for airflow. That was an important part of this design, was the connection between the kids and everything else happening. And also the gradient of privacy. They can close the windows. They can close the window and have their privacy if they want up there. So that's that. So from that window, this is what it looks like. They can look at the kitchen, big windows up here. It's a beautiful space. This is a little drone shot from the exterior plaster process. This is last week. So this is really cool. We applied the exterior plaster, and it's fully natural lime plaster, kind of what they use in Greece or and all around Europe, the buildings there. Applied the lime plaster in a mere 2 days. Done. We use a spray, like a mortar sprayer. I'll show that in a second. So this is a time lapse of the finish coat going on. So the one person on the spray, there's one on mixer, one on sprayer, and then a few following behind, polishing things, smoothing it out, touching all the details up. And look up, this video was 40 minutes. We did the whole front wall in what normally, the siding on this would take hours. And this is, you know, this replaces the vapor barrier. This replaces sheathing. This is an all-in-one system that happened way quicker and at a cheaper material cost too. Yeah, beautiful plaster. It's a nice earthen finish with a skirt and a hot and cold water spigot, which is really simple to add in. You know, good outlets, and then trim gets added on top of the plaster around it all. We don't have those pictures yet because that just happened a few days ago. This is what it is now as of a week ago. So the family is moving in, which is why we couldn't do the in-person tour. The timing just didn't work out. And so we're here virtually, sharing this beautiful process and connecting and answering any questions that y'all may have.
Thank you, Aaron.
Yeah, thank you.
We have a couple of questions in the chat. Jenny has stepped away for the in-person tour. So we want to get to these questions and then allow time for folks to hop off and check out those tours in person.
Cool.
So it looks like a question from Evan and Diane. What type of sealer product do you use to make the clay product suitable for shower floors?
Yeah, so for showers, I wouldn't necessarily use it for shower floors. That's a little tricky. And the reason is because soap. Soap does have a chemical reaction with the lime. So the blend that we use for the shower floors is a mix that we've been playing with. So there's a product called Decopause, and then that's a recycled cement product that uses a soy-based polymerizing something. And they have their own sealer system, and it's a thin plaster you mix up. And so that's what we use primarily for like the really watertight shower system. So my simple answer to that is Decopause.
Great, thank you. We had a question from Pat Park for both projects. Would there be a cost per square foot estimate? Do you have an estimate in mind for this project in particular?
Yeah, it really depends on the land, the infrastructure. I mean, there's a lot of factors there. This was a little bit higher per square foot because of how small the footprint needed to be. So we had to find, struck the right balance there. It's hard to say. So then it was about 325 or so. I'd say now it'd be more like 350 or so would be a good budget baseline. I'd say the middle of the bell curve, I'd say, is between 350 and 400 per square foot for a high performance natural building like this with these systems. And there's ways to reduce it. My goal is to, and we're on track to do this. My goal is to design and develop the most cost-effective, highest performance buildings on the market. So we're working on it.
Fantastic, thank you. We just had a question come in from JB. How does foundation hold up to the earthquakes? How are the foundation to the walls designed for seismic activity?
Yeah, good question. So I'll just take you in. This is kind of the modeling software that I use. And this is how we do virtual design sessions with the client. This is kind of a really fun, engaging process. The engineering was tricky on this one because we had such a big retaining wall in the back, and I would definitely do this differently next time. This is definitely a big lesson. I wouldn't use the house as the retaining wall for a few reasons. I would do a specific like eco block at a 2-degree slope to hold back the hillside in an earthquake, and then build the wall. But it's great. I mean, the foundation is standard. We have a traditional concrete footer, and then the blocks get stacked right on the footer pad and can get buried. So you have to put a little mortar against the blocks just to create that little bit of gap, but you could bury the blocks on each side. But overall, yeah, really well. This was fully engineered, fully permitted, fully to code. Natural house.
Fantastic. And real quick, Erin, what is the spelling on the shower product that you mentioned for
Oh, sure.
Decopause?
Yeah, let me type that out real quick.
Great, thank you so much. Oh,
Yeah.
fantastic. Thank you.
For those that are just listening to the recording that don't have access to the chat, it's DECO-POZ, Decopause.
Fantastic. Thank you,
Yep.
Erin. Well, prior to wrapping up today's virtual Northwest Green Home Tours, does anyone else have any other questions for Erin? That was a fantastic presentation, Erin. Thank you.
Thank you. Yeah, so I was looking forward to, and again, my contact information, I'll just put that back up on the in the chat. If you have any further questions on a chat, feel free to text me, call me, email me. I'm very available to talk about this stuff. I can also plug in with an existing design team. I do a lot of consulting services. I work for a lot of architects. And I do a lot of heavy lifting, drafting and modeling and natural building consulting. So feel free to reach out for anything you need. Any other questions you have about this process or anything you got going on. Again, thank you all so much for being here. Thank you, Nina.
Thank you so much, Erin. Alrighty, and folks, I welcome you to check out the northwestgreenhometour.org page for other live tours today. We've got some great, wonderful homes and small businesses on the tour this year. Again, that's nwgreenhometour.org, and there you can find the map of sites to tour today. And bring a raincoat just in case. I'll go ahead and post the link in the chat. And thank you so much for joining today's virtual tours. And we look forward to seeing you all out in the in-person tours. And thank you again so much to our presenters, Erin with Earth Homes and the Carlisle, as well as First Lamp team with the Passive House home in Wallingford. Thank you all so much. Again, a recording of this event will be made available for folks who registered about a week or two after. And also check out our Northwest Eco Building Guild membership options, where virtual tours and other event recordings are accessible at any time. It's a great membership to provide education and programming for green homes across the region. So we welcome you to check out our membership options with the Northwest Eco Building Guild, which I will also post in the chat. And a huge round of applause and thanks again to you, Erin, as well as the team with Carlisle and First Lamp. And I wish you all a happy Saturday. Stay dry, stay safe, and stay healthy. Thanks all.
Thank you, everyone. And just for, I'm going to stick on until 11:30 or so. If anyone has any desire to connect.
Yeah,
face-to-face.
likewise. I'll keep the session going until 11:30, just in case anyone wants to chime in and ask questions, Erin.
Cool.
Great job.
Thank you. And you too. It's good work. Setting all this up and hosting this. A lot of work. So yeah, if anyone, I think maybe we can just turn this into like a little impromptu, informal panel discussion where people could just, or a little seminar roundtable. People can chime in, say hi, ask any specifics, questions, whatever. You got us for the next 8 minutes. Use it.
Hello. Can you hear me?
Hello. Indeed.
Yes.
Hey, I'm Shauna.
Hi, Shauna.
This is weird because I can't see my own view. So anyway, thanks for your time. I've just started the process of interviewing architects and design build firms for a remodel in North Seattle. I wondered, I mean, lots of things. This has been fantastic information, but if we were to sign on the dotted line tomorrow, how long does it take to even get started on a project like this with permitting and so forth?
Remodel in North Seattle.
Yep. 1930 Tudor that basically needs everything done. Just think of it that way. We would
Yeah.
like to save the foundation, and it's got what my husband calls good bones, the basic wood structure I would love to preserve. But other than that, mostly a total rebuild.
Oh, sure. Yeah. Okay. I've only done one big project up in Seattle. And that permitting was a nightmare. And so I chose not to do it again. But I learned a lot, and that was earlier on in my career. But I do work with a few architects in Seattle that do a lot of permitting there. Does anyone have more information on? I know in Wallingford, yeah, you guys are closer.
Yep. Hi, I can add a little insight. I think the queue, as it is for most firms, is going to vary quite a bit. I know, with a signed contract, most of our clients are waiting somewhere between 6 and 8 months before we can begin. Most projects like you described, a lot of the timeline depends on the client availability and how quickly clients make decisions, just as much as it depends on how fast we're able to draw and kind of find a design that you love. But usually the design process itself, once we're started, around 6 months. For a smaller project, it can be as little as 3. But we deal with, there's a lot of other scheduling factors. There's a lot of people on the project other than just architects. We have to hire engineers, and there's separate waiting lists to get on to each of those people's schedule also. So 6 to 9 months is a good design time to kind of earmark for yourself once design has begun. And then permitting time for projects like you described, that's 3 to 4 months in Seattle right now is a good time budget. You'll probably be able to do it faster than 4. But again, a lot of it just depends on which review track your project takes, which reviewers are in town or on vacation or, short staffed or whatever it may be. But 3 to 4 months is a good, safe time budget for a permit review. So if you add, I would say 9 months to a year design time, like once you begin with an architect to having your building permit in hand, 9 months to a year is a safe bet. And if it helps, like most builders need that much time to get a project on their schedule and have their staff available to begin a new project also. So that's kind of a broad view of what timeline looks like these days for those projects.
And you're with Carlisle, right?
No, I'm with First Lamp. It's an architecture company that I'm a co-founder and co-owner of. The 2 guys that presented with me both work for Carlisle. Yeah.
Okay, you're Kevin.
I'm Kevin. That's
yeah.
me.
Okay. All right.
Yeah.
Thank you.
Yeah.
Thank you.
And I'm Dan.
Brian.
From the contractor perspective, what Kevin just shared is also, I would say, very accurate. Typically, it's up to around a year to design and get a permit and build. And, from the production standpoint, that works as well. Like our company is easily booked out a year right now, even a little more if you really look at it honestly. Things move around and can change. Sometimes jobs drop off. You can fit stuff in, but yeah, definitely around a year just to get permits in hand and be ready to build. You might not start building exactly when you have the permits in hand. It can vary a lot, but always happy to talk to folks and about what's going on in the industry and how your projects can work out and get built. So,
and with just starting a big project like this, it's, as I mentioned, I've talked to a couple architects, but is that the recommended first step, talk an architect first and then
Oh, yeah.
Use a builder that the architect, I mean, do you guys kind of need to know each other and have a working relationship already? Or what, what can you say about design build firms and the ones that kind of do it all? And yeah, I'm sorry, I don't mean to dominate the conversation, but.
First Lamp started, my company started as a design build firm. And we were a design build firm for 10 or 11 years. And it really affected, we're now architecture only, but when clients come to us without a builder attached yet to the project, that's one of the first things that we do is, we get enough of a design started, but then we do the builder interview process pretty early. And so then we approach the project with a design build sort of setup, so that we'll have design meetings and someone from the builder's office is there in the room, and we get price guidance and commitment, and it's general and it's loose because it's so early in the project, but it is really important to just kind of get a good emotional commitment to the project gathered up early.
I also feel like having that balance between the architect and the contractor who will be building the project really helps, because it's much more collaborative. By the time you get ready to build, everybody really has their heads in the game. And also there are sometimes things that like the architect will see or the builder might see that the other person might not. So you can catch some of the oversights during the design process rather than during production, which can help speed things along and just deliver a better product. So, yeah.
Thank you.
Yeah, you're welcome.
It's an overwhelming process from my standpoint.
Yeah. We make sure that all of our office staff kind of understands that, like, for every single one of our clients, like, it's a ton of money, it's a ton of time, and it's your home. Like, it's all of these things that are just like these giant parts of your life. So yeah, it's a big project.
Thanks for sharing that perspective, you all with First Lamp and Carlisle. It's very helpful. And thank you, Shauna, for your questions. Are there any other questions for our architects and builders today? We have just a couple more minutes. And then I think we'll go ahead and stop today's virtual tours and let y'all get some in-person tours. Well, wonderful. Well, thank you all again so much for a list and map of the next tours in person. Please visit our website, nwgreenhometour.org. I want to say thank you all again so much for joining. Thanks to our sponsors as well as our presenters today. And we look forward to seeing you out, out in the in-person tours. Thanks again so much.
All right. Thank you, Nina.
Thank you.
Thank you all. Have a great day.
All right.
Well.
You too.
Thank you.
You too.
Bye-bye.
Thanks, everyone. Bye.
Bye.